The volume, V of H, in cubic meters of a liquid in a large vessel depends on the height in meters of the liquid in the vessel and is given by this integral here. V of H is the integral from 0 to h of e to the negative x squared over 100 with respect to x, where h is between 0 and 15. We're asked to determine dv dh when the height is 0.5 meters. So, well, if this is v, and we know that differentiation and integration are just reverse processes, it follows that dv dh is e to the negative x squared over 100. And if we want to evaluate that, when h is equal to 0.5, correction here, that should actually be an h, because that was the limit there. When h is 0.5, we would get e to the negative 0.5 squared over 100, and calculating that gives me 0.9975, and that would be in meters cubed per minute. What is the meaning of our answer to part A? That is the rate of change of volume with respect to height when h is equal to 0.5 meters. The height of the liquid depends on the time t seconds as follows. H of t is 3t squared minus t plus 4 for values of t greater than or equal to 0. Determine dh dt when the height is 6 meters. Well, dh dt is going to be 6t take away 1 dh dt when h is equal to 6 is what we want. Well, let's think about h being equal to 6. So what we would get is 6 is equal to 3t squared minus t plus 4. That gives me 3t squared minus t minus 2 equals 0. We can actually factorize that, but you could solve it on the class pad as well. 3t plus 2, t take 1 is equal to 0, and so t is negative 2/3, or t is equal to 1, and that one is out of range, so it's got to be this one. And so we get 6 times 1, take away 1, which is equal to 5, and that would be in meters per second. Use the chain rule to determine dv dt when the height is 6 meters. So dv dt is, using the chain rule, dv dh dh dt. Well, dv dh we established was e to the negative h squared on 100, and now we've got to times it by dh dt, which is 5. And so when the height is 6, we can get, oh, that's going to be 6 there. So 6 squared over 100 times 5, and then we just calculate that. 3.488 meters cubed per second. Given the volume of liquid at 2 seconds is 8.439 cubic meters, use the incremental formula to estimate the volume 0.1 seconds later. Okay, so delta V is going to be dV dt delta t. Now, h of 2, remember we've got the formula for h here, is going to be 3 times 2 squared, so that's 12. Take away 2, add 4, is equal to 14. So we know that h is equal to 14. So we get e to the negative 14 squared over 100. Now this is dv dt, so we're going to multiply here by dh dt, but this is when t is equal to 2, and our dh dt is that. So it's 6 times 2, take away 1, and then multiply by the 0.1. That's our delta t. So that is approximately 0.155. So v of 2.1 is going to be approximately 8.439, which was the value given here, plus the 0.155. And that gives us 8.594 cubic meters.